Good evening, everyone. Welcome back again. And this is the lecture of engineering mathematics. And today we are going to learn the system of linear equations. In the last lecture, we have learned how to find out the rank of a matrix and how to find out the rank of a matrix with a non-square matrix. That is where the number of rows and the number of columns are not equal. Today, we are going to learn the system of linear equation solutions with the help of the rank of matrix. And after finding the rank of matrix, how we are going to solve the system of linear equations. Though there are many other ways to find out the system of the solution of the system of linear equations, but one of the most efficient methods is the rank of a matrix method. That is, by using the matrix, and the system of linear equations can be represented as a matrix form. Okay, I already have an I means discussed about these particular things with an example. Today also we are going to learn about this. So this is one of the examples of system of linear equations. And in these equations, you can see there are three variables: x, y, and z. When the number of variables are increased, the complexity of the system of linear equations are also increased. And it is also very difficult to solve if the equations are large, number of equations are large, that is large, and number of variables are also increasing. So as the number of variable increases, the system also becomes complex and it is very difficult to solve it. If the are two variables, then we can use a very simple method by adding or subtracting the equations with some coefficient multiplier. Okay, as according to as necessary, we can multiply with some coefficients with the equation, and either we add or subtract according to our convenience, and then we can solve the equations. Okay, I think all of you already know how to solve the system of linear equations in two variables. This is very easy to solve. But this is here you can see the system of linear equations has three different variables. Okay, so we will use the method of rank, finding the rank of the matrix, and then how to find out the solution of the system of equations. So here, uh, let me explain what are the variables here. This is x first variable, y second variable, and z is the third variable. Okay, three variables are there: a1, a2, and a3. These are the coefficients, and d1, this is the term on right hand side, that is equality. Okay, so similarly second and third equations also getting b1, b2, and b3 are as coefficients, and c1, c2, c3 as coefficients respectively, and xyz are the variables. The variables are same for all the equations. So we can rewrite this particular form of, that is system of linear equations, in matrix form. Okay, it is very easy to represent in matrix form. You can see a1, a2, a3, b1, b2, b3, and c1, c2, c3. These forms a coefficient matrix like this: a1, a2, a3, b1, b2, b3, and c1, c2, c3. So this matrix is called coefficient matrix. And we introduce a variable, a vector, which is x, y, z vector. This is a column vector xyz, and right hand side we will also introduce another column vector d1, d2, d3. Okay, so you can see if you multiply, that is if you multiply this coefficient matrix with this xyz column vector, you can get these three equations back again. Okay, and in the right hand side, each and every equations, you can get three equations exactly according to the previous equations if we multiply the coefficient matrix with this xyz vector, that is the column vector. Then exactly we will get the same equations as before, and right hand side d1, d2 and d3 are acting as a acts as a right hand side of each equations. So now I'm going to explain how to form this system of linear equations. And there are many sectors, many industrial applications are there, many other applications in economics, in all other cases, means uh, many aspects, fields are there where system of linear equations are generated. Okay, so in this system of generate after generating, we need to solve the system of linear equations. So right now I'm going to give you an example of how to generate a system of linear equations with a real life example. So let us consider here an industry, and this industry has is manufacturing three different kinds of product. The first product is range, the second product is gears, and the third product is a hammer. Okay, hammer and needle. Okay, and these three products, this company or this manufacturing industry is going to means make these kinds of products with some amounts, and to produce this they need to incur some production cost. And I have a list of production cost in different scenario. There are three scenarios here: case 1, case 2 and case 3. In first case 1, in this scenario you can see the ranges. If 50 unit ranges are produced, the production cost is 1000 rupees. If 60 units of gears are produced, the production cost is 2000 rupees. And 70 units of hammers are produced, then the production cost is 2500 rupees. Or better to explain it in dollars: $1000, $2000 and $2500. Okay, similarly, in second case we can see if 30 unit of ranges are produced, then the cost is $600. 40 units of gears incurs $1200, and 50 units of hammers incurs $1400. Similarly, in case 3, 100 units of ranges incurs $2000, 200 units of gears it incurs $4200, and 300 units of hammer it incurs $5000. Now how we model this, means how can we explain this by using the system of linear equations. Okay, so let me explain first. First, 50 units, if the ranges, we are talking about the ranges. Okay, let us suppose first we introduce three variables x, y and z. Okay, and these three variables are the unit production cost of ranges. This is the unit production cost, this is for range. And y is the unit production cost for gears, and z is the unit production cost for uh, this is hammers, let us suppose. Okay, now what we need here, we actually need to find out the values of x, y and z. Okay, so first there are, you can see, so it is 50, 30 and 100. So you can see here 50 units of range. Now look at this, the first scenario. Okay, case 1. What are the ranges here? The ranges are 50. Okay, so 50 units of range, and let us suppose that we use x, okay, x amount of range. Sorry, x is the per unit cost. So unit is 50. Okay, so 50 unit of range, that is 50x. Okay, this uh, is equal to 1000. That is, we can actually easily find out here, is equal to 1000. Okay, 50 units of ranges are 1000. 60 units of gears, so 60 into y is equal to 2000. And 70 units of means it is 2500. Okay, so if I add these three equations, okay, so it will get 50x plus 60y plus 70z is equal to, if we add these three, so 1000 plus 200 plus 2500. This is the total cost. Okay, so it can form the first equation. So it means 50x plus 60y plus 70z is equal to 1000 plus 200, 2500 plus 200. So it is 3500. So 3700. So this is equation number 1. This is the first equation we can form here. Okay, similarly we can get the second equation, which is the 30x. That is, x is the a unit production cost for ranges. So 30 into x means 30 units have been produced, ranges are produced, and 30 into x, it must be equal to the 600. Basically, if you solve first, second and third easily, you can solve it by using the first equation. This is also a linear equation, and you can easily solve x equal to 1000 by 50, and what is the value of x, you can easily solve it. But just for giving you the, for the sake of example, I am giving you how can you form a system of linear equations and how can you solve it. So it is 30x 40y plus 50z. Okay, and this is of course addition of these three, so it is 0. Okay, this is also 0, and this is, okay, 12. So 3200. And this is equation number 2. Similarly, for the first, so 100, third case, 100x 2200y and 300z. Okay, so it is 100x plus 200y plus 300z is equal to, now you can 5000, 2000, 7000, so 11200. So equation number 3. So these forms a system of linear equations, you can see. So what is the coefficient matrix here? 50, 60, 70, 30, 40, 50, 100, 200, 300. This forms a, so 50, 60, 70, 30, 40, 50, and 100, 200, 300. Okay, x, y, z, this is equal to, the B matrix is 3700, 3200, and 11200. So this forms the system of linear equations, and we can convert this system of linear equations in the form of this matrix. Okay, now I am going to solve a matrix. This is a very complex matrix, and you can see that the numbers are very huge. Okay, so now I'm going to solve a system of linear equations. Okay, so there are in system of linear equations you need to learn some to solve it. You need to first learn some notations. The first abbreviation it is called, that is notation, it is called uh, the coefficient matrix, which I already, sorry, okay, first one is coefficient matrix, coefficient matrix, and the second one is augmented matrix. So coefficient matrix and augmented matrix. Coefficient matrix, you already know what is a coefficient matrix. Now augmented matrix, let us discuss what is an augmented matrix. Okay, so let us start with a very small matrix like this. Suppose 2x, okay, plus 3y is equal to 5, and 3x plus 5y is equal to 10. Okay, these two system of linear equations are there. Only I have considered two equations with two variables just for the sake of simplicity. Okay, so what is the coefficient matrix here? Okay, so I am going to rewrite this system of linear equations by using matrix form with ax, okay, is equal to b. Okay, so what is a matrix? A is the coefficient matrix. Now I can write the coefficient matrix here. You can see 2 3 3 5. So 2 3 3 5. This is the coefficient matrix. What is the vector? So vector, you can see xy, there are xy. And what is the right hand side? 5 10. So b will be 5 and 10. Okay, so this matrix is the coefficient matrix. Now what is augmented matrix? Now augmented matrix, if I combine a and b matrix together in a single matrix, then it will form an augmented matrix. How? So augmented matrix, okay, it is represented as a b. Just we combine these two matrices, and these two matrices, so 2 3 3 5 and 5 10. What is the b matrix? 5 10 is the b matrix. 5 10. Okay, I have just give here dotted line, just as a, it acts as a partition of this, but it is not necessary. Okay, I just give this partition just to make you understand that what is the b matrix and what is the a matrix, that is the coefficient matrix. Okay, it is not necessary to give the partition in between them. So this entire matrix is called augmented. So augmented matrix. Okay, now we need to find the rank of this augmented matrix, and as well as the rank of the coefficient matrix. Okay, so if I use this augmented matrix, the coefficient matrix rank and the augmented matrix rank both can be easily found. Okay, so in a single matrix, in augmented matrix, operations on the augmented matrix can give you the rank of both coefficient and augmented together. Okay, now what is the, we need to learn some rules. Not all system of linear equations has solutions. This is the one thing we cannot say that all system of linear equations has solutions. Okay, so let me explain. Okay, so that is the system of equations, what kind of system of equations are there which does not have any solution, and what kind of system of linear equations are there which has the solutions. Okay, so point one is, if the rank of the rank of coefficient matrix is equal to the rank of augmented matrix, then and only then we can say that the system of linear equations has solutions. And this is called consistent. If the solution has, then it is called consistent system. Consistent system means if the system of linear equations has some solutions, then it is called consistent systems. Okay, and second rule is, if the rank of coefficient matrix is not equal to the rank of augmented matrix, then this system is called inconsistent. Inconsistent systems. And inconsistent system does not have any solution. Okay, so inconsistent system means the system which does not have any solution. The system is called inconsistent. Okay, so these two basic rules we need to learn, and we need to and for this we need, of course we need to find out the rank of the matrix for coefficient and augmented both. Okay, now let us give you an example. Okay, for rank of the matrix. Sorry. So let me. Okay, so let us start with an example. I will start with a 3 cross 3 matrix. Okay, matrix example of to find out the rank of a 3 cross 3 matrix. Okay, and 2 cross 2 matrix rank, it is very easy to find. So let us forget about that, and let us think about only 3 cross 3 matrix. Okay, so let us explain the matrix first. So first system is, okay, example, the first system, it is 2x plus 2y plus z. So 2x plus 2y plus z, this is equal to 5. The second system is x minus y plus z, this is equal to 1. And third system is 3x plus y plus 2z is equal to 4. So this is the third system. Okay, so we first find out the matrix form of this system of linear equations. So what is our coefficient matrix? Let us find out the coefficient matrix first. Okay, so you can see it is, of course, that first row is 2 2 and 1. So 2 2 1, this is the first row. So first row, it comes from the first equation. The coefficients of the first equation gives us the first row. Coefficient of the second equations gives us the second row. Okay, so what are the coefficients of the second equations? Second equation coefficient, first is 1, second one is -1, third one is again 1. Okay, this is the second row. And the third one, 3 1 2. Okay, what is the vector? Vector is x, y, z. And what is the right hand side? The B matrix 5, 1, 4. Okay. So directly first now, second step is we find the augmented matrix first. I'm using the short form. So what is the augmented matrix? 2, 2, 1. Just we join together the B matrix, the right hand side matrix, and the coefficient matrix together. So 1, minus 1, 1, 3, 1, 2. Okay. And the right hand side it is 5, 1, 4. Okay, now let us find out what is the rank of this augmented matrix. Okay, so I already explained how to find out the rank of the matrix. So I'm not repeating the whole method again. So directly I'm going to solve this one. So the first equation, so you can see if I interchange the first and second row together, then the first element of the first row, it becomes 1. So our first operation is R1, that is interchanging R1 and R2. So it becomes 1, minus 1, 1, 1, 2, 2, 1, 5, and third row as it is 1, 3, 1, 2, 4. Okay, now what is our target? Our target is to make this element, that is this element and this element, as 0. So accordingly we will use our row operations. So what is the row operations? R2 minus 2R1 and R3 minus 3R1. Okay, so after this row operations, so it becomes 1. Of course this 2 will be 1, 0, 0. First row will be unchanged. Okay, from the second row it will be changed. So R2 minus 2R1, so 2 plus 2 it becomes 4. Okay. And this one R2 1 minus 2 it will be minus 1, and this is 5 minus 2 it is 3. Similarly third row R3 minus 3R1, so it is 1 plus 3, so it becomes 4 again. And 2 minus 3 minus 1, this is 4 minus 3, sorry, yes, it's 4, and it is minus 3, yes, it is 1. Okay, now what is our last operations? Our last operation, we can make this element as 1, or directly we can do this. You can see the third row and the second row of the coefficient matrix is similar, 0, 4, minus 1, 0, 4, minus 1. So simply we can use the operations R3 minus R2, and it will all make a 0. Okay, so actually our target is to make this element. Okay, make this element as 0 now. Okay, to make this element as 0, it is better to convert this element, that is the second diagonal element, as 1. Okay, but you can see the second diagonal element and this element, these two are same element here. So these two elements, if I use R3 minus R2 operation, then it can be easily 0. This one will be easily 0. And for this, we don't have to convert the second, uh, there is the diagonal element, as 1. We don't have to make it 1. So directly we can use here R3 minus R2. Basically we use to make the second diagonal element or all diagonal elements as 1, just to simplify our operation. Okay, it is not exactly necessary, but here you can see these two elements, the upper and lower, both elements are same, so we don't need to make the second diagonal as 1. Simply we can use R3 minus R2 operation. So it is 1 minus 1 1 1, so 0 4 minus 1 3. Now the third opposite is 0. This also becomes 0, and this also becomes 0 here, because 1 plus 1, and this one is 1 minus 3, so it becomes minus 2. Okay, so look at this matrix. Actually, this matrix is a non-square matrix. Okay, the number of rows are 3 and the number of columns are 4. It's a non-square matrix, but our required form is achieved now. Okay, so these two elements are 0 and this element is also 0, so we don't go further because we already have the rank of this matrix. Okay, so what is the rank of this entire matrix? The entire matrix is AB matrix, that is the augmented matrix. Okay, and this matrix, that is this one, just make me square box. This matrix is the coefficient matrix. The coefficient matrix. Now we need two ranks. First one, what is the rank of augmented matrix, that is AB? Okay, so the rank of augmented matrix AB, you can see what is the rank. So number of non-zero rows. The first row, is it non-zero? No. The second row, this is also non-zero row. Third row, no, this is not also non-zero rows. Okay, because 0 0 0 minus 2. So not all elements of this row are 0. So that is why we say that all three rows are non-zero. So what is the rank of AB matrix, that is the entire matrix? Of course it is 3. Now we are going to find out the rank of A matrix, that is the coefficient matrix, that is this square box matrix. Okay, now forget about this right hand side. Okay, let us forget about the right hand side. Now we will concentrate on only this square box. Now what is the rank of this matrix? Only this square box. How many non-zero rows are there? So first row, this is non-zero. The second row, this is also non-zero. The third row, this is a 0 row. So number of non-zero rows here is only 2. So the rank of A, that is coefficient matrix, is 2 here. Are they same? No. So since the rank of coefficient matrix and the rank of augmented matrix, they are not equal, so we will say that these three systems are actually inconsistent system. Inconsistent. Okay, now since the system is inconsistent, so we can say that the solution doesn't exist. So in this case we cannot find any solution of this matrix. Okay, so let us also repeat these particular things later according to your requirement. So first we find, okay, we first find the augmented matrix. First we um, make this augmented matrix. How to make the augmented matrix? I already told, coefficient matrix and the right hand side, that is the B matrix, join them together. This is the coefficient matrix: 2 2 1 1 minus 1 1 and 3 1 2. This matrix is the coefficient matrix, and right hand side matrix, the column matrix 5 1 4, is the right hand side matrix. Just join them together in a single matrix, it will give you the augmented matrix. Okay, next we need to use the elementary operations on this entire augmented matrix. Okay, and we need to find out the rank of this augmented matrix. This matrix is a non-square matrix. Okay, always it will be a non-square matrix, and we need to find the rank of this. So we use the elementary row operations as we have discussed in earlier videos. So use the operations, and we find, at last we find the last matrix, that is this one. This matrix is the final matrix. Okay, so final matrix, we will find two different ranks. First rank is the rank of the entire matrix, that is AB matrix, entire matrix. So what is the rank of the entire matrix? Just count the number of non-zero rows. The first row 1 minus 1 1 1, non-zero row. Second row is 0 4 minus 1 3. This is also non-zero. The third row is 0 0 0 minus 2. This is also non-zero row. Okay, so the rank of the entire matrix, of course, we can find it is 3. Okay, next rank is rank of the coefficient matrix only. That is, coefficient matrix means I'm highlighting it. So this is the coefficient matrix only. Okay, this is the coefficient matrix only. Okay, so we need to find the rank of only this matrix now. Okay, so what is the rank of only this matrix? Now count the number of rows of only this particular matrix. First row is 1 minus 1 1, non-zero. Second row is 0 4 minus 1, non-zero. Third row is 0 0 0. This is the 0 row. So what is the number of non-zero rows here? 1 2. Only 2 non-zero rows here. So the rank of the coefficient matrix is 2. So now we need to check whether these two ranks, AB and A, these two ranks are equal or not. No, this is not equal. If these two ranks are not equal, we say the system of linear equation, this system is inconsistent. It means that the system does not have any solution. Okay, I think now it is clear for everybody. Okay, so there are three cases now. So this example gives us the system of linear equations which is inconsistent, that is no solution is there, which is having no solution. Now if the system of linear equation has the solution, let us uh, remove it first, has a solution, then we find there are two cases. Solution may be a single solution, that is unique solution, or infinite number of solutions. Okay, single solution, everybody that is only single value of x, single value of y, and the single value of z can be found. System of, if it is single solution, that is means everybody knows, if it is solution, then we can find a single value of x and y, or single value of x and y and z. Okay, but sometimes it also happens we can find infinite number of solutions, that is infinite number of values of x, y, and z. How is it possible? Let me discuss in this particular example. Okay, so let us discuss about this. The system of linear equation here, it is first equation is 2x minus y plus z is equal to 2. This is first equation. Second equation is 6x minus 3y plus 3z is equal to 6, And the third equation is 4x minus 2y plus 2z is equal to 4. Okay, so these three equations. Now let us find out the matrix. A matrix is coefficient matrix 2 minus 1 1. Second row will be 6 minus 3 3. Third row will be 4 minus 2 2. Okay, this is the A matrix. Okay, the vector is xyz, and B matrix is the right hand side 2 6 and 4. Okay, now what is the augmented matrix? So augmented matrix here, A and B together. So A matrix is 2 minus 1 1, 6 minus 3 3, 4 minus 2 2. Sorry. Oh. And what is the B matrix? B matrix is 2 6 4. So this is the augmented matrix. Now we need to use elementary row operations to find out the rank of the augmented matrix first, and then after that the rank of the coefficient matrix can automatically be found. Okay, so what is our first operation here? So you can see the first operation here, it is, you can see that the first element, that is 2, it is not 1. Second element is 6, third element is, so any the first 2 6 and 4, nobody, no element is there is 1. Okay, so our first target, what is our target? Our target is to make our target is to make this element 6 and 4, these two elements, as 0 with respect to the first, that is the first row first element. Okay, so we can use first we can make the first row first element as 1, that is 1 by 2 into r1, that is row 1. So we can make the first element as 1, or we can use different operations. Okay, like that is r2 is r2 minus 3r1 r2 minus 3r1, that can also be done. So it is 2 and this is 6. Okay, so we can use this operation, similar, r2 minus 2r1. Sorry. Okay, without using the, okay, without using the first row first element as, without making the first row first element as 1, we can directly use the operation as r2, this is row 2, r2, okay, minus 3 into r1. This can also make this element as 0. So you can use it. R2 means r2 element is 6, minus 3 into 2, this is also 6. So 6 minus 6 becomes 0. Similarly, how to make this element as 0? R3 minus 2 into r1. So you can use these operations also directly, okay, to make these two elements as 0. Okay, now what we can find here? So we can find the first equation, it is 2 minus 1 1 2. Second one, it is 0. Okay, this element r2 means minus 3, minus 3 into, so plus 3, this is also 0. Now this one is 3 minus of minus of 3, so it is also 0. 6, so 6 minus 3 into 2, this is also 0. Okay, So now let us find the last one, 4 and 2. So 4 2, it is 0, of course it is 0. Second one is minus 2 plus 2, okay, this is also 0. Third one is 2 minus 2, this is also 0. Fourth one, it is 4 and 2, this is also 0. Now look at this. Okay, so easily it can be found, are the rank of augmented matrix and the rank of the coefficient matrix equal? Yes, of course they are equal. Both ranks are, what is the rank of the entire matrix, that is augmented matrix? The rank of the entire matrix, that is AB, is matrix. You can see how many non-zero rows are there. Only the first row is non-zero. 2 minus 1 1 2. First row is non-zero. Second row is 0. Third row is also 0. So only 1 is the rank. Now come to the coefficient matrix only. Okay, so rank of the coefficient matrix A. How many non-zero rows are there? First row is 2 minus 1 1. Non-zero. Second row is 0 0 0. Third row is 0 0 0. So again this is also 1. Are both the ranks same? Yes. Ranks are same. It means system is consistent. Okay, it means it has some solutions, but the problem is how many solutions are there. So you can see, if I convert this matrix to matrix form again, so what will happen? It will happen like this: 2 into x from the first row. From the first row, we can get 2 into x minus 1 into y plus 1 into z. This is equal to 2. Second row, from the second row, 0 into x plus 0 into y plus 0 into z. This is equal to 0. The third row gives us 0 into x plus 0 into y plus 0 into z is equal to 0. So it means these two equations actually doesn't exist, because all are 0 0 0, 0 equal to 0. We don't need to write these two equations. Only single equation exists here, which is 2x minus minus y plus z is equal to 2. Only single equation is there. Okay, so how can you find out a solution of a single equation? No other equation is there, only single equation. No, it is cannot be found in a single solution, cannot be found, but you can find infinite number of solutions in this, from this equation. So how can you get it? Okay, let us suppose, okay, infinite number of solution, there is a rule to find out infinite number of solution. Okay, so only our equation is this, only single equation is there and no other equation is there. So it means that first let us consider, okay, you need to learn this particular logic here. Okay, this logic is very important, and you need to means you need to understand this very carefully. Otherwise it is quite difficult to get it. Okay, how can you get this infinite number of solution from this single equation? Okay, so first let us consider, okay, we consider x equal to c. C is any real number. Okay, c is any real number and it is a constant. Okay, constant means it can be varied. It is any real number, you can vary it according to yourself. Okay, this is a solution, is a solution. Okay, so this solution x equal to c, actually you can consider the value of c according to yourself. You can change it, you can, so as you change the value of x, okay, x equal to 1, you can get another solution. X equal to 2, you can get another solution. X equal to 3, you can get another solution, and so on. Okay. Now, since there are only single equation, you you have to consider another value of other variable. Let us suppose y equal to d is another solution, is a solution of y. Is a solution of y. Okay. So these two solutions are considered. Since the number of variables are 3 and the number of equation is 1, so you have to consider the solution of any two variables, either xy or yz or xz. Okay. So it means, carefully listen, number of variables are 3, number of equation is 1. So that is why you have to consider the solution of predefined solution of any two variables. Okay. Now you can find the value of the third variable, that is z variable, by using this equation. Okay. Let us put the value of x and y in this equation. 2 into c minus d plus z is equal to 2. So what is the value of z? Now z equal to 2 minus 2c plus d. This is the value of z. So what are the solutions we are getting? We get three solutions. Sorry, not three. It is a single solution actually. So values of x, y, z. So what is the x, y, z vector here? The solution is x equal to c, y equal to d, and z equal to 2 minus 2c minus d. So this is the solution. This is infinite number of solutions, infinitely many solutions. Why? Because you can change the value of c and d according to yourself. So for each changes, you can get different solutions. Okay, but the form of the solution, it will be always c, d, and 2 minus 2c minus d, like this. It will always follow this particular relation. But the number of solution is infinite. Okay. Now let us see another interesting thing. We erase these things. Okay. Now look at the equation carefully. Three equations carefully. Look at all the three equations. What is the first equation? 2x minus y minus z equal to 2. Look at here what we got. We also get the same thing. 2x minus y plus z equal to 2. Look at this. And this equation, look at this. If we just take 3 as common, so 3, this also becomes 2x minus y plus z is equal to 6. And nullify 3 and 6 both sides, we are getting the same equations. 2x minus y plus z is equal to 2. Isn't it the same equation at the first one? Look at this. These two equations are same. Now go to the third equation and take 2 as common, and we are getting 2x minus y plus z is equal to 4. Just nullify 2 and 4 both sides, we are getting 2x minus y plus z is equal to 2. Isn't it the same equation? So first, second, and third, all these three equations are actually same equations and nothing else. So only single equation is given, but the number of variables are 3. Okay, so if these kinds of solutions are there, you can identify, if you can identify that the all three equations are same, no need to use the lot of matrix operations. Okay, easily you can say that yes, all these three equations are same and can be converted into only one equation. Then by using this rule, these considerations, you can find the infinite solution. What are the infinite solutions of this equation? Okay, now go to the previous, sorry, next row, and let us give you another example of this infinite number of solution example. Okay, let me use another slide. Let me add it. Just keep it. Yeah, I think it's visible now. Is it visible now? No. Not visible. Now it's visible. Visible. Okay, let us give another example of a system of linear equations. Okay, now in this case, I am giving you the equations like this. Suppose, okay, this is equation number one, and the equation number two is, let us suppose, equation number two, and the third equation is this. These three equations. Okay, here you can see, if I find the without finding the rank of the equations, you can see here first two equations are actually same. The first equation is 2x. Now from the second equation, what I can find, from the, if I take 2s common, it becomes 2x plus 3y plus z is equal to 4, and we nullify 2 and 2 both sides, and we are getting 2x plus 3y plus z, this is equal to 2. So the first and the second equations are actually same. So these three system of linear equations, it actually becomes actually system of two linear equations. So okay, so it is 2x plus 3y plus z is equal to 2, and the third equation is 3x plus 2y plus z is equal to 6. Okay, so actually these two. So here also you can find the number of here also we can say number of variables are uh, greater and number of equation is less. Now in this case we need to first find out the rank of the matrix, the rank of the augmented and rank of the coefficient matrix. Okay, because two equations we are getting, so we can find the rank here. If the ranks are equal, then we can say that here also we can find the infinite number of solutions. Okay, so infinite number of, if the infinite number of solutions are there, we can find in this case. So we can also, but here what happens, here we can say that since number of equation is 2 here, we don't need to consider the value of two variables. Since number of variables are 3, but the equation is increased here, equation is not 1, equation is 2 here. Okay, so here we can consider only the value of single variable, that is suppose z. Okay, but we can find this by using the matrix operation again. Okay, matrix operation, and finding the rank of the matrix, and means after the elementary row operations. Okay, we can find one variable. Okay, one variable value easily, and then one variable we have to consider. Okay, so and the third one, that is the, for unique solution, we already have already done one example for unique solution in our last lecture. Okay, but one example of unique solution we also will be we can also solve it. Okay, but I will explain that unique solution example in the next class, not for today. So I think all you have learned how to system of linear equations. Okay, in use of, in the, by the use of matrix, the rank of the matrix, and the matrix operations, linear, elementary linear row operations, and after finding the rank of the matrix, you also learned the inconsistent and consistent equations, and you also learned what is the infinite number of solutions, what is single solution, that is unique solution, and what is no solution. So basically in system of linear equations, these three cases happens: no solution, single solution, that is the unique solution, and infinite number of solutions. Okay, so three different cases so we have learned here. I will also give you more example of system of linear equations, that is unique solution examples, and infinite number of solution examples, where the number of variables is 3 and number of equation is 2. Okay, so see you in the next class. So thank you for being with us, and you can also visit the website www.innovaworld.info for more information.